Good morning, madam and my fellow friends. My name is Susan Wu Siu Sian, matrix number PC22085, and we are group number 8. Today we will present about the joining process, mechanical assembly, which is about the permanent and non-permanent. And this is all the group member in our group, which is Faiz, Susan, and Rosiman. Okay, next we talk about what is the joining process. Joining process is the method which is used to assemble two or more components into a single part, which is using the technique that can be permanent, semi-permanent, or temporary, which is non-permanent. And why is the mechanical assembly important in the manufacturing? It's because is the final process that creates the functional and reliable product by accurately joining the component together. And let me brief a little bit for the permanent and non-permanent. For the permanent joints, it cannot be disassembled without damage, resulting in a strong, often lead-proof connection for the long-term using. For the non-permanent joints, it can be assembled and disassembled multiple times without damaging the part and making them ideal for the maintenance and repair. Okay, next let us talk about the overview of mechanical assembly. Mechanical assembly is the process of joining individual mechanical components to create the functional sub-assembly or complete the machine. And where we use the mechanical assembly, in the automotive industry, we can use it for the car body panel, and at the aerospace industry, we can use it for the aircraft fuselage, and in the electronics and electrical industry, we can use it for the print circuit boards. And last, in the construction and infrastructure industry, we can use it for the steel structure. For the pros of the mechanical assembly is no need the heat and is reliable and fast. For the cons for the mechanical assembly is sometimes not removable and is require high accuracy. Okay, next is about the mechanical assembly for the non-permanent. Non-permanent mechanical assembly is the process of joining parts with fastener that can be removed without damaging the component, allowing the disassembly and reassembly. The parts that we can use the non-component and non-permanent mechanical assembly is the manufacturing equipment, automotive and aerospace industrial, consumer products industry, and the construction industry. Okay, next is about the type of non-permanent joint. There are 7 types of non-permanent joint. The first one is ball joint, which is use a ball and nuts to secure the part. The second one is screw joint. It's use a screw that can directly fasten into a component. And the third one is pin joint. Use a pin to hold or align the parts. The key joint is use a key to connect a shaft and hub. Quarter joint is use a quarter pin to fix the rods and shaft. For the step fit joint is use the flexible plastic feature that snap into the place. And for the last one, clamping joint is use the clamps or rings to hold the component together.
Assalamualaikum. My name is Muhammad Rosman bin Zahari, PC 22086. For the advantage of non-permanent joint is easy to assemble and disassemble, good for maintenance or repair, usable, adjustable and reduced downtime. For disadvantage of non-permanent joint is risk of loosening, wear and corrosion, misalignment, require more component and lastly heavier and sometimes costlier. Okay, next, mechanical assembly for permanent joint. Mechanical assembly concept of permanent joint is the process of joining parts together in a way that they cannot be easily disassembled without causing damage to the component. The application that used in manufacturing equipment, automotive and aerospace, construction, consumer product, shipbuilding, lastly for energy and infrastructure. This is type of permanent joint, riveted joint, welded joint, brazed joint, soldered, adhesive, shrink fit, and press fit joint. Next, this is advantage and disadvantage of permanent joint. For the advantage of permanent joint is high strength and durability, resistant to vibration, corrosion and wear, seamless and leak-proof connection. For disadvantage of permanent joint is inflexibility, where the assembly result is component damage. Next, time consuming and labor intensive to create. And lastly, limited reusability to lead the poor sustainability.
Assalamualaikum, my name is Muhammad Faiz Hakim Abdul Manan. My metric number is PC22080 and today I want to present the comparison between permanent and non-permanent. First criteria is disassembly, which is the permanent cannot be disassembly and the non-permanent can be disassembly. And for the strength, permanent is moderate to high while non-permanent is moderate. Next is cost. Permanent is low to high cost while the non-permanent is low to the moderate cost. The maintenance for the permanent is very hard while the non-permanent is easy. The common use for the permanent is for aerospace and electronics while the non-permanent usually is the machinery and also automotive. Next is selection criteria. Selecting the right joining process is important to ensure the final product is strong, reliable, economical, and suitable for its function. The choice of joining method depends on the several key factors such as material type. Different material require different joining method. For example, steel can be welded easily, but plastic need adhesive bonding or heat welding. Second is the thickness of materials. There are two types of material, which is thick materials and also thin materials. Thick material is a welding, brazing, and also mechanical fastening. For thin material is soldering, adhesive bonding, and also spot welding. Lastly is the joint design and geometry. Complex shapes may restrict certain method. Some joint need access from only one side, for example, spot welding. Next is common defect or failure. First is misalignment. Parts are not properly aligned before joining, and it will cause the poor fixture design, human error, and improper setup. Second is the loose joint. Insufficient tightening or poor bonding also can be common in mechanical fastening, which is bolt, screw, and also rivets. Third is the over-tightening, excessive torque on fastener. It also can damage the thread, deform part, or cause cracking. Lastly is the crack. Micro crack or visible crack at the joint, mostly because of the high stress, improper cooling, vibration, and also thermal shock. Next is the case study, and this is the example for the case study that based on our method, which is a comprehensive review on structure joining technique in the marine industry. Next is the video demonstration. This is the demonstration that can be watched for better understanding about our process, which is the riveting demo, both tightening animation and also adhesive bonding process. So that's all from our group. Thank you.